All right, today we're going to decode the secret language of the human body. We're talking about the system that turns every single ache, break, and repair into a universal story. One that doctors, researchers, and insurers can all understand perfectly. Let's jump right in.
So let's start with a question. How do you make sure that a doctor in Tokyo and a researcher in London are talking about the exact same injury? You can't just say broken arm, right? That doesn't cut it. You need a universal system. You need a code.
And that system is the ICD-10-CM. Now, I want you to think of this less as just a boring list of codes and more like a global language for medicine. It's all about precision, turning these really complex conditions into crystal clear data that can be shared and understood anywhere in the world.
So in this explainer, we're going to build this language from the ground up. We'll start with the basic rules, then we'll apply them to really common stuff like back pain and arthritis. We're even going to follow the entire journey of a broken bone, from that first injury all the way to the final fix.
Okay, first things first. Before we can start writing these medical stories, we need to learn the alphabet and the rules of grammar. This is the absolute foundation of musculoskeletal coding.
And this is our playground, the entire framework that holds us up and lets us move around. I mean, look at it. With hundreds of bones, joints, and muscles, you can see why a system built on absolute precision is, well, it's not just nice to have, it's essential.
These right here are the fundamental questions that every single coder has to answer. It is not enough to say a leg is injured. Which bone? Is it the right leg or the left one? Specificity is absolutely everything. And when you have conditions that are linked, you use combination codes to tell that whole interconnected story with just one entry. And right away, we hit a really important distinction. Are we talking about the bone itself or the joint where two bones connect? A problem with the bone, like osteoporosis that makes it brittle, is coded completely differently than a problem with the joint, like arthritis. One is about the actual structure, the other is about the connection. It's a subtle difference, but it's a crucial one.
Okay, so we've got the rules. Let's put them to the test on one of the most complex and, honestly, one of the most common areas of the body, the spine. When you're talking about back pain, the tiny details in the code matter a lot.
So on the left, you see the big picture, our body's central pillar. But the real story, the stuff that coders are dealing with day to day, often happens at the micro level you see on the right there between the individual vertebrae. That's where discs can herniate and where nerves get pinched.
And this brings us to a huge point. Not all herniated discs are created equal, and they're definitely not coded the same way. The most important question is it affecting the spinal cord itself? If the answer is yes, that condition is called myelopathy, and its seriousness means it gets a completely different and much more specific code.
And just to be super clear here, myelopathy means the information superhighway between your body and your brain has been damaged. It's like there's a major traffic jam. This is a very serious diagnosis, and the code has to reflect that reality with absolute, undeniable clarity.
All right, let's shift our focus from the spine and move over to the joints. This is where we find arthritis, one of the most common conditions coders will ever see. But here's the thing, arthritis isn't just a single story. It has a whole bunch of different causes.
We're going to zoom in on the most common type, which is osteoarthritis. This is what you'd call a degenerative disease, and you can pretty much think of it as the natural wear and tear on our body's hinges after a lifetime of movement.
But even within this one type, there's another key distinction. Primary osteoarthritis is that general wear and tear we just talked about. But secondary? Well, that means there's a specific culprit, maybe a past injury or a genetic issue. This is where a good coder really puts on their detective hat to find that root cause and assign the most accurate code. And sometimes, arthritis isn't the main story at all. It's just a chapter in a much bigger book. You can see here that conditions like Lyme disease or diabetes can actually cause arthritis. In these cases, coders use multiple codes to link them together, telling the full story. This patient has arthritis because they have this other underlying disease. It's a much richer narrative.
Okay, now for something a little more dramatic, fractures. When a bone breaks, the code needs to capture way more than just what broke. It has to tell us how it broke, and even more importantly, why. This right here is a critical fork in the road for any coder. A traumatic fracture is from an accident, a fall or car crash. But a pathological fracture happens because the bone was already weak from a disease like osteoporosis. And you absolutely cannot code both on the same bone because they tell two completely different stories about that patient's overall health.
And this is where it gets really cool. The code itself can actually track a patient's recovery over time. It's all in the 7th character. Just one letter tells the whole story. A is for that initial active treatment. D means the patient is in the routine healing phase. And S is used for any long-term complications down the road. It's a full timeline in a single character. Amazing. So finally, after we've diagnosed the problem, we have to code the solution. This is where we document how the body is being rebuilt, whether that's through a joint replacement or a spinal fusion. You know, coding the procedure requires the exact same level of insane detail as the diagnosis. What kind of implant was used? Did the surgeon come in from the front or from the back? Every single one of these details changes the code, adding another precise layer to the patient's record.
Now, with something complex like a spinal fusion, the name of the procedure is practically a code in itself. If you see anterior in the name, like an ALF, it means the surgeon approached from the front. Posterior, in PLIF, means they came from the back. The name literally gives you a roadmap of what the surgeon did.
And this diagram shows you exactly what those terms mean in the real world. You can see the different paths a surgeon can take. Each approach is a different type of surgery. It means a different recovery for the patient, and so of course each one gets its own unique code. It's all about capturing that precise procedural story.
So what's the big takeaway here? At the end of the day, coding is storytelling. It just has a very strict set of rules. It demands precision about location, about cause. It's about linking issues together to tell the whole story. It follows a patient's journey over time. And it documents not just the problem, but also the fix. So remember this, every single code represents a human story. And when we gather millions of these coded stories, what larger patterns start to emerge? What could all this data tell us about disease, about recovery, about the future of medicine? The stories are all right there, in the data, just waiting for us to read them.